In this video, we're going to take a look at the similarity that exists in right triangles. This goes along with our learning target. I can verify the similarity of two geometric figures. In right triangles, if we draw the altitude to the hypotenuse of the right triangle, it's going to divide the triangle into two triangles that are similar to the original triangle and similar to each other. Here's what that means. I'm going to start by drawing my altitude from vertex B, and I'm going to connect it at a right angle with my opposite side. Since I'm doing this in a right triangle, I know, and I'm going to go ahead and label this point here D, I know that this triangle on the left, this triangle on the right, and the entire big triangle are similar to each other. So what this is saying is that triangle ABC is similar to triangle ADB, and that's also similar to triangle BDC. In order to talk about these relationships, first we need to talk about the geometric mean. And what this is for any two positive numbers, a and b, the geometric mean of a and b is the positive number x, such that a over x equals b, x over b. So let's say we want to find the geometric mean of the numbers 2 and 50. So we want to look for whatever number x would allow 2 over x to be equal to x over 50. In order to solve this problem, I'm going to start by cross multiplying. So that gives me x times x equals 2 times 50, or x squared equals 100. To undo squared, I'm going to square root both sides, and I'm going to be left with x equals 10. So the geometric mean of 2 and 50 is 10. We have two corollaries that go along with this right triangle similarity. The first one says the length of the altitude to the hypotenuse is the geometric mean of the lengths of the segments of the hypotenuse. Alright, so what this is saying is that AD, this chunk of the hypotenuse, and the height is going to be in the same relationship as the height to the other length of hypotenuse. So our geometric mean would be AD over BD is equal to BD over DC. When taking a look at this, we notice that in the triangle on the left, we have the shorter leg over the height is equal to, and if we look at the triangle on the right, it's the shorter leg over the height. So short leg over height equals short leg over height. Our second corollary states the altitude of the hypotenuse of a right triangle intersects it so that the length of each leg is the geometric mean of the length of its adjacent segment of the hypotenuse and the length of the entire hypotenuse. So what that's saying is that the entire hypotenuse of the big triangle AC over AB is equal to AB over AD. We're taking a look at the relationship between the entire big right triangle and the one on the left. So taking a look at what this means, AC is the hypotenuse of the big triangle, AB is the shortest leg of the big triangle. That's going to be equal to the hypotenuse of the little triangle over the short leg of the little triangle. We have another relationship if we want to compare the big triangle to the triangle on the right. We can say that AC over AB, AC over BC is equal to BC over CD. Again, we're comparing the length of the entire hypotenuse of the big triangle over the leg is equal to the hypotenuse of the triangle on the right over the leg. Okay, let's try this out. Looking at this first sample problem, I notice that I have both parts of my hypotenuse labeled for my big triangle, and I notice that the height of my big triangle is missing. It looks to me that I'm going to be addressing corollary number 1. Corollary number 1 states that AD over BD is equal to BD over DC. We have the leg of the longer leg of the triangle on the left over the height equals the longer leg of the triangle on the right over the height. So I'm going to plug in some values. So I have 27 over x, because I don't know what that value is equal to x over 9. From here I'm going to cross multiply. That gives me x times x, or x squared, equals 27 times 9, or x squared equals 243. To get x all by itself, I'm going to square root both sides, and I end up with x is approximately 15.59. Taking a look at this next problem, I notice that both chunks of my hypotenuse of my big triangle are given, and I'm missing the height of the big triangle. So this looks like it's very similar to our last problem, and we use corollary number 1. So we're going to solve for y, and again we're going to use corollary number 1, which states that AD over BD is equal to BD over DC. So we plug in some values. We end up with 4 over y is equal to y over 5. We cross multiply, which gives us y squared equals 20. We take the square root on both sides, and we end up with y is approximately 4.47. In order to solve for x, it looks like I'm going to have to turn to corollary number 2, which states that AC over AB is equal to AB over AD. I'm going to calculate my length of AC, which 4 plus 5 gives us 9 centimeters. Now I'm going to plug in my values. I have 9 over x is equal to x over 4. From here I'll cross multiply, which gives me x squared equals 36. I square root both sides, and I'm left with x equals 6.